And to finish our worksheet off, we've got a couple interesting questions with logarithms. Let's do example, I believe this is 13. Check my paper here. Example 13. We've got 12 raised to the log base 12, 144. And the directions are saying, rewrite this in simplest form. As I'm looking at the problem, I see that it's already in exponential form, and really what I want to focus in on is this piece here. A log base 12 with an answer of 144 would equal what? In other words, 12 raised to what power gives me 144? And the solution to that is what's going to go here. 12 raised to the second, or 12 squared, is 144. So it means I could replace all of this with a simple 2. And so I could say 12 squared, in this case, turns out to be 144. Final answer, 144. Let's do another one. Actually, I'm going to call this 13.2. We'll do the similar concept here, except let me start with a different base, because I think maybe that's a little confusing as to why that just kept going back and forth. Let's say I had a 5 here instead of the 12, and I raise it to log base 2, 8. As I look at that exponential form, log base 2, 8, that in and of itself can be simplified. Log base 2, 8 is, it's asking 2 raised to what power is 8? 2 raised to the third is 8. So I could replace the log base 2, 8 with 3. This would just be a 5 to the third power. And of course 5 to the third power is 5 times 5 is 125. 5 times 5 is 25. 25 times 5 is 125. So this would be 125. That would be your final answer. Let's do another. I've got one that says example 14, 9 log base 3 of 81. Once again, I have to look at this, just that exponent, log base 3, 81. 3 raised to what power is 81? As I think about that, that would be a 4. So I come back over here and say 9 to the 4th power is equal to, because I'm just replacing the log base 381 with the 4, what it was equal to. Just put that 4 there. 9 to the 4th, well 9 times 9 is 81, and I myself need to go to the calculator. I don't know what 9 to the 4th is. 9 raised to the 4th power is 6561. 6561. 6561. So that's pretty large. Now I hesitated between example 13 and 14 because the worksheet was giving some strange results. I'm going to show you just a quick introduction of how to put some of these obscure ones into your calculator and see what that does for us. We're going to call this example number 15. This says 5 log base 5, 17. As I'm looking at this, I don't know what 5 raised to gives me 17. So I go off to the side here. It says log base 5, 17. I don't know what I could raise 5 to. 5 to what power gives me 17? I know 5 to the first is 5, and 5 squared is 25. So this must fall somewhere between 1 and 2, but I don't know what that value is. And so the question is, how would I figure that out? I know where this is going to lead, but I want to make sure that you understand how to find this if you're confused. So in my calculator, and this is done differently for the 83 versus the 84, you can hit the log button on here, if I remember correctly. You can also do your math, and there's a log. Where is that button at? Oh, log base. So what I did was I hit math, and then there's a log base, and what that does is it gives you the structure of everything. So you could put your base of 5 in there, and you can put your 17 in there, and when I hit enter, notice that I'm getting this number that what I just explained to you was going to fall somewhere between 1 and 2, because 5 to the first is 1, or 5 to the first is 5, and 5 squared is 25. Since this fell somewhere in between there, I knew that the exponent had to be somewhere in between there. Now, I don't believe that's what they're wanting you to do on this. So I got the 1 and change here. As I put that 1 and change on this, 5 raised to the 1.7603 dot dot dot. And remember, just like we did in the last chapter, keep all those decimals. You would need those. But think about what's going on now. They're asking you to raise 5 raised to something between the 1 and 2 power. Without putting it in the calculator, do you, I don't know, think about what that could possibly be? Wouldn't it take us back to this answer right here? And so I believe our answer is 17. Why? Because of what I was using as logic here. 5 raised to something between 1 and 2 gives me 17. Isn't that what they're telling me to do then? And if I go back to my calculator, I do 5 raised to that last answer. That's what that gives me. It's going to give me 17.00. There's rounding error in your calculator, but for all intents and purposes, that's 17. And so you don't have to use your calculator. And if you're that kid that has that 83, I don't believe you have that option when you do math. You go down to log base. I don't believe that's there. So we'll have to learn a little different method that I'm not ready to divulge just yet, because I want you to do more thinking tonight than anything. I don't really want you using that calculator to come up with these answers. And then we'll see how that works for you. So there's 15 different examples on how to use logs. It's an introduction to using logs, understanding how you have a base, an exponent, and a solution.